Oh, hi there! So, Siddhant, if that's your real name, what's your New Year's resolution?
I want to be good at maths.
Well, good luck, son. But do you want me to teach you?
Yes, I want to learn exponents and logarithms.
Well, this is your lucky day, because I will teach you about exponents and logarithms. So, Siddhant, how was it? Did you learn my lessons?
Yes, Aisha. Here you go.
Wow.
Now I will show you what I learned. So exponents and logarithms can be divided into two parts, exponents and logarithms. First we'll explore exponents because based on that we understand logarithms. Exponents has types. The first one would be positive whole numbers. These numbers represent the number of times the base is times by itself. So say in case the power was 5, then the base was times by itself 5 times. Then there is the negative whole numbers. These numbers they represent the reciprocal of the base with the power of the absolute value. So in case say it's 5 to the power of negative 5, then we have 1 over 5 to the power of 5 to the power of 5. Then there's the fractional powers. There's the numerator and the denominator. The denominator is the root of the power, the base with the numerator power. So say in case 5 to the power of 5 over 2, then we would have square root of 5 to the power of 5. Then finally there are special powers. Anything to the power of 1 will result in itself, while anything to the power of 0 will result in 1. These are the types of powers. And there is properties of powers. There are 5 properties. So the base with a certain power, when multiplied with another same base with the different with the power, will result in the base having the sum of the two initial powers, which would mean 5 to the power of 2 times 5 to the power of 3 will result in 5 to the power of 5. And the opposite is true, where in case you divide a base to the power by another same base with a power, you will get the result would be the base to the power of the difference, which in case say 5 to the power of 5 divided by 5 to the power of 2, then you would get 5 to the power of 3. When you put a base to a power in parentheses and then put another power to the parentheses, it would result will be that the result of both of the powers will be the new power to the base. So say in case it's 5 to the power of 2 in parentheses to the power of 3, then the new parentheses, the new power would be 5 to the power of 6. When putting a fraction to the power, then all of the fraction, then the whole of the fraction would have that power. So say in case 1 over 5 to the power of 3, then it would be 1 to the power of 3 over 5 to the power of 3. Then there is the multiplication in parentheses to the power. So a times b in parentheses to the power of a certain number. It would result in a to the power times b to the power. Say 5 times 3 in parentheses to the power of 2. Then we would have 5 to the power of 2 times 3 to the power of 2. Exponential functions. Exponential functions are written as a base to the power of a variable. The base needs to be above 0. In this case, the domain is any real number while the range is above 0. 0 is the horizontal asymptote. If a is greater than 0, a means the base, but smaller than 1, it will go from top left of the second quadrant of the graph to the bottom right of the first quadrant while passing through the coordinates 0, 1. The opposite would be true for a base bigger than 1. Description and special logs. So a base to a power results in a product. If we put it into a log with a base and then in a product, we should get the power. So say in case 5 to the power of 2 equals to 25, then log to the base 5, 25 should equal 2. ln is a special log, often called natural log. It can also be stated as log to the base e. E is the Euler's number, which is around 2.71. Now, going on to log's property. It is opposite of the properties of powers. If two logs with the same base are added, then the two products are multiplied. So, say in case log to the base 2, 5, plus log to the base 2, 3, then we should get log to the base 2, 15. If two logs with the same base are subtracted, then the product of the first log is divided by the product of the second log, which is when the product of the log has a power, the power can be put in front of the log as a factor. Factor meaning it is multiplied by the log. A log where the base and the product are the same will always result in 1. A log where the product is 1 will always result in 0. Change of base. When changing a base of a log, it becomes fraction. The numerator will be a log with the new base product, while the denominator will be a log with a new base and has the old base as the product. Exponential equations. These equations are given in the form of a base to the power of a variable or function equals to product. They can be rearranged as log with the base product equals to variable or function. From here it can be solved using the methods that are usually used involving like equations. So now going on to the relationship with exponents. If log with base product equals to power, then log with base product can also be written as power. This would result in the base to the power of log with base product equals to base to a power. Here we can cancel the base and the log with the base of the right hand side. The results will be product equals a base to a power. Then finally there's logarithmic functions. These functions are given as a log to the base variable. The base in this case must be higher than 0 and not equal 1. If the base is higher than 0 and lower than 1, then the line will start from the left of the first quadrant to the right of the fourth quadrant, while passing through the coordinates 1, 0. The opposite is true if the base is bigger than 1. That's all.
Subscribe here. Please.